Here in this part 2 video of solving identities, we're still looking for different ways of reasoning through our trig information so that we can use those tricks and those information to make left side equal to right to be able to prove more difficult questions. So the first thing that we have to go through here is we have sine theta equals opposite over hypotenuse. Now what there is there's also reciprocal trig ratios. And we know that when you take the reciprocal, that just means that your numerator becomes your denominator and your denominator becomes your numerator. So the reciprocal of sine is called cosecant. And you can see it up there. So in short, we just put CSC. So for cos, if I was to take the reciprocal, that means I just flip the A and the H upside down. For cos, the reciprocal name is secant. And we represent that by saying CEC. Just squeeze that in there. It's equal to that. I left out my theta there. For tan theta, the reciprocal would be to take the A and put it on top and the O and put it on the bottom. And that's called cotangent, now that it's the reciprocal. So that's also what you see here typed out, is we've just taken our trig ratios and taken the reciprocal of them so that we have more information. Now when we're solving these reciprocal identities, let's look here. We have cosecant. Cosecant here can also be said to be 1 over sine theta. Just the reciprocal. Secant means that you've taken the reciprocal of cos, which is 1 over cos. So this will help us in the future as well. These are all notes, videos that you may need to watch again when you start to see some of the bigger questions. Now let's remember that our quotient identity told us that sine theta over cos theta is always equal to tan theta. That was the quotient identity from the last video. So we can see here that if we're talking cotangent now, the reciprocal of tan theta, we know that cotangent is equal to cos over sine. Again, becoming useful to us in further questions that we have to do proofs for. So we will use these identities to rewrite each side in terms of sine or cosine before we proceed. Most identities are easier to prove this way. So let's see what it is that we're talking about here. So secant, we know, is equal to 1 over cos. That may help us. And on the left side, our tan theta, we know, is sine theta over cos theta. And our cosecant is 1 over sine theta. So again, we work with our most complicated side first to try and simplify it. So that'll be the right side. I see that my sine theta and my sine theta will cancel out. So on my left side, I'm equal to 1 over cos theta. And there it is already. The left side is equal to the right side. So I've proven our original statement true, that secant theta will always be equal to tan theta multiplied by cosecant theta. So our last ones here, you can see that sometimes we're going to have to factor first and then simplify. So if you remember that from the first introduction video, that was one of our steps. Now it'll make sense. I'm just going to parallel this first. Keep in mind, if we had x squared, an unknown, minus x times y. In our very first unit, we would have common factored out the x, which would have left us with x minus y. So just remember that these are just unknowns here. So if there's something common in both, there's a sign common in both of those, we can common factor that out. So there's a sine x common in the first term here and in the second term here. So if I factor out 1 sine x from the first term, it's going to leave me with 1 sine x. And if I factor it out of the second term, all I'm left with is cos x. Now, eventually in the future, these little tricks will also help us to try and balance or make left side equal to right side. So let's look at this one here, this factoring question. I'm just going to parallel it with basic variables, how we did it in our first unit. If I had x squared minus y squared, we would have done a differences squared here. That's when you square rooted the first term, square rooted the last term, and then you rewrote it again with addition. One of our easier factoring ways. So if we have it here with sine theta squared and cos theta squared, we do the exact same thing. So I square root my first term, which is just sine x. I square root my second term, which is just cos x. And then I rewrite it again with addition. All right, and our last question, just for the sake of having space, I'm going to rewrite that. Question C, rewrite this question. Sine squared x plus 7 sine x. And what this question should read there, we can't see it, is plus 12. What I'm going to do is parallel this one as well from our first unit. If we had x squared plus 7x plus 12, what we always asked ourselves is I need two numbers that multiply to be 12 and add together to be 7. So our answer would look like this, our magic numbers we said, x plus 4 and x plus 3. So we do the exact same thing here, it's just that we have sine x instead. So our magic numbers are still 4 and 3, but when we write our first set of brackets, we have sine x plus 4 and sine x plus 3, because those are our unknowns. And if we were to expand that out, sine times sine would be sine squared. If you continued to expand it out, you would end up back at the original question. So now that we have all of our tricks for solving identities, we'll begin to actually practice tomorrow in class. So tomorrow I'll give you a handout and we'll practice together to be sure that all of this begins to make sense.